I have always dreamed of racing on a track through my city. To achieve that in a simulation, I used photogrammetry technique to scan reality. Photogrammetry is basically a method for reconstruction of 3D models from photographs. Before everything, we obviously have to gather photos. The most important thing for the photos is them to be as sharp as possible. No motion blur or out of focus images. I'm using a GoPro 7 camera and recording a video, from which I later extract frames. To reduce the motion blur, you should set shutter speed as fast as possible. In GoPro case, it is 1/400. I also increased image contrast and sharpness in the settings. Next important thing is how you take images. The object has to be photographed from all angles. In our case, with the road and city, we take the camera in 4 directions: forward, backward, left and right. I used a single camera and made 4 runs with it. For riding through the city, I'm using a bicycle. My city does not have huge traffic and it is easy riding a bike. Bicycle has few advantages over a car. It is easier to maneuver through the traffic. When you record sideways video, you can go closer to the sidewalk and that shot can capture a larger part of the road and surroundings. Bicycle is much slower than a car and all of the traffic is just passing by you, and you cannot get in this situation when vehicle in front constantly blocks part of the view. When you take images for photogrammetry, it is quite important, you can even say mandatory, that it is cloudy outside. On cloudy weather there are no shadows, which would be baked into textures later. Also, lighting is more even, and there will not be under or overexposed parts on the images. I also choose to drive on weekends and early in the morning so that the traffic would be as infrequent as possible, so as few vehicles interfere. You now plan the route you want to recreate and capture the video. Google Earth is useful for that. To extract images from a video, I used Adobe Premiere because of a greater flexibility. But you can also use Reality Capture. Just drag and drop video file in Reality Capture, choose a folder where images to be saved, and interval the frames are extracted at. Back in Premiere, we import all the videos we want images extracted. Place video from every run on a separate video track. After that, I made new sequences to group video segments because GoPro splits video to more files with longer recording. Next, we edit video recorded sideways. Here is the part where I had to stop with the bike and wait for traffic, so I'll cut out that part. Then we nest the sideways videos. In this part, a garbage truck obstructs most of the shot, so I'm going to replace that part of the truck with a different video I recorded in another run. Find that part in that other recording and overlay it over the part where the truck is. Next, we are going to speed up the video so it has the amount of frames we need. Here I control-clicked the time format to change it to frames. In my experiments, I found out that an image on every 1.5 meters or 2 meters is good amount for good reconstruction. In this case, I extracted an image every 1.5 meters. To calculate how much frames is that, we divide track length to the image distance interval. In this case, the track length is 2220 meters, and we divide it by 1.5 meters, which I rounded up to 1400 images. So we need to speed up the videos for them to have 1400 images each. In Premiere, you press Ctrl R and just enter the frame number. After that, I just visually checked the distance between frames. The opposite direction video's frame numbering will not match the same position on the track. So, I reversed videos on opposite directions for image numbers to match. That way, images, for example 200 to 400, with every camera will be approximately at the same part of the track. Then we send all that images for render. Choose PNG sequence. We are going to Images folder, where we will store all our images. Then create new folder for this camera, main forward. Inside of that we are going to create a reality capture folder structure, which is documented in reality capture help. Texture is for images that are going to be used for texturing the mesh. This folder is going to be for high resolution images. Next one is Geometry. This folder will store lower resolution images for reconstruction. And final folder is Mask, which will store black and white mask images. Then we do all of that for the drone images. Drone images can be extracted at every 5 meters. No need to make them more dense because they are further away. When all the videos are queued to batch, we can hit render. Now we will check all the images if there is some blurry photos like this one and delete them. And also if a car obstructs most of the view like here and here. All of these images are somewhat useless for track reconstruction. Next, we are going to reduce the image size for geometry calculation. That way, the PPI price for reality capture license is lower. Also, the reconstruction and working in reality capture is much faster. I am using Faststone Image Viewer for this. Open the images in texture folder, select them all, go to Batch Convert Images, check Use Advanced Options. In Options, check Resize and Percentage. I choose 50%, that will make a 4K initial image to HD one. The converted images are saved in Geometry folder for that camera. Hit Convert. I didn't resize drone images because they are further away and lower in number, so I estimated they should need higher resolution. When all the cameras are converted, we need to mask all the moving elements in the images, like cars and people. Photogrammetry calculation assumes that everything in the images is stationary, so moving objects will complicate calculation and worsen reconstruction result. Reality capture does not have its own masking solution, so you need an external program to create black and white mask images. I used Photoshop for that. We will create an action to automate the process a bit. First, select the part of the image that has to be masked. Then we will create new action, RC masking. What it will do is fill the inside of the selection black and outside white. Black parts in the mask are excluded, only white part is used in reconstruction. Do not save this image now, cause it will overwrite geometry image. The way we do it is first to open some number of images in Photoshop. Then select parts to be masked in all open images. When that is finished, go to File, Automate, Batch. We choose the action we created. For source, choose Open Files. That are all images currently opened in Photoshop. For destination option, choose Folder. Locate the mask folder for that camera you are masking. And the Photoshop does the rest for you. When we go to Mask folder now, we can see black and white images Photoshop generated for masking in reality capture. And then we continue this tedious work of masking for next few days. It took me more than 10 hours to complete this. When all of this is complete, images extracted from a video, deleted blurred and obstructed images, converted to lower resolution and masked, we can now begin photogrammetry reconstruction. We can import all of the images in reality capture to see what result we can get quickly. We will import only GoPro cameras with geometry and mask images only. Texture is not needed now. The important thing for more successful image alignment is to set all of the same cameras in one group, suggesting to reality capture that all of that images have the same lens calibration. In our case, all of the GoPro images are in one group. In this test, that are all the images imported. When an image is selected, here we have calibration group for that image. It is -1, which means no group. Select all the images, click here on images, then we get these settings where we click group and constant to notify reality capture that all of these selected images are taken with the identical camera and have the same lens calibration. These images are now in group 0. When this is set up, we can click on the Align Images to see what is going to happen. The result has two components, meaning that reality capture couldn't align all the images in one object. This larger part, where most of the track is reconstructed, is not usable. The street here is misaligned and the cameras here are condensed. Let's try only the drone images now. Again, we need to group images for more accurate reconstruction. Here are also two components. This larger one is quite misaligned for some reason. This roundabout, for example, appears 2 times. Then in alignment settings, I experimented with image overlap, detector sensitivity and reprojection error, but results were not better. To try to align all imported images and make better reconstruction, reality capture uses control points. Control point is essentially a manually selected one exact feature on multiple images. We will select one camera in 3D view to add a point. If camera gizmos are too big or small, you can change their size here, under Scene tab. Control points should be placed on a flat surface in some corner-like feature with high contrast. Corner because that is the easiest way to choose the same pixel on multiple images most accurately, and high contrast because it is easily visible. Under Alignment tab, we click Control Points and then on the spot we want a point to be added. This point then appears here. Then to select next camera, we first need to turn off Control Point. When next camera is selected, we turn on Control Points again. F3 is shortcut for this. It is going to be switched on and off a lot. If we now just click on this image where our feature is, we are creating a new control point, point 1. We want to tell the program that the spot here is the same as point 0. So after deleting point 1, we select point 0 and then click on the spot where it should be. When we add more than one point, Reality Capture estimates the other cameras that should have the same feature in them, and adds them as suggestions here in gray. We can click on them and see where the control point approximation is. Here we see an error in approximation. This also means that the current reconstruction is not quite accurate, which we previously saw with road misalignment. We then check and correct the other suggestions. Also, we can select more images that are not suggested. Then more control points should be added. I stopped here with only 4 points and tried if it improves the reconstruction, but it was kind of the opposite. More control points. Still not good. I then went back to project with drone images only to try to align that better. Here is one more way to add control points. You can click in 3D view and Reality Capture adds a point with all the cameras that feature is visible in, which should be then checked and corrected. After some time and 59 control points added, I managed to align images pretty accurately. What I realized is that if not all the cameras are aligned, here in alignment settings you can increase the reprojection error and Reality Capture will manage to align more images. The default value is 2, I increased it to 3. Here is the accuracy of the control points, I also increased that to 4. For the GoPro cameras, I didn't manage to align them all together, so I'll do it in sections and then later merge all that parts together with the drone reconstructed part. But first I will export all the control points I made in previous project where all GoPro cameras were imported, so I don't have to do it again. To export, you need to input license first. Enter your PIN and save license file. Then in Alignment tab, go to Export Control Points. Now to reconstruct only this D section of the track. Here I noted image numbers where the section starts and ends, but we will use few images more backward and forward, so we will have an overlap in these sections. I'm not sure if this is necessary or even beneficial at all for later merging, but I felt I should make an overlap. Here I noted every section start and end image number including the overlap. We then import these images for all GoPro cameras. We are doing that for geometry and mask images only. Don't forget to group images. Click Align. This alignment looks good, even without control points, but we are going to import them anyway to increase accuracy. On Alignment tab, import control points. Then select the file with control points we exported earlier. This notifies us that some images are missing. That is because we exported points from all the images, and here we just have one section of the track. Control points are now added. We can click Align again. This looks fine, but for some reason point cloud is placed sideways. To correct that, go to Side View with numpad key 4 or 6. In Reconstruction tab, click Set Ground Plane and rotate the point cloud correctly. Now this project can be saved and exported as component. Exported components will be imported in another project and merged together. On Alignment tab, Export, Registration and save the file. When all these sections are exported as components, we will start a new project and import them one by one. Components imported this way have a star next to them. The images used in component are also imported. The images now lose their calibration group settings, and that should stay ungrouped like it is. Grouping them again now seems to break component merging and alignment. To merge these two components now, we need to add them some mutual control points. We choose one control point in one component, then find that exact feature on another. I added the point in 3D view and checked its accuracy. These are now two separate control points, point G4 and point 63. To merge them and tell Reality Capture that it is the same feature, we just select all the cameras in one control point and drag them to the other. Then we add and merge some more mutual control points. When this is done, we click on Merge Components, so Reality Capture does not realign all the images, but only tries to merge imported components. Here is the result. The components are merged well. Here we have the new merged component. These two with a star are imported ones. We can now continue to import other components and more control points and merge them all. All components are now merged, and we need to check for misalignments. Here, for example, we see that this wall appears twice. This is, of course, solved with more control points. I made two more here. Align again. The wall is better now. Then we check all the rest. Here, while importing control points, I got double points. We will merge these points by dragging images from one to another, as we did previously. These 2 points, A and A1, are specifically created for distance measurement. I measured the distance between these 2 points in real world, and we are now going to define that measurement in Reality Capture. Under Alignment tab, click Define Distance and select one, then the other point. Then this constraint is created. We will name it distance A. Then enter the measured distance here. It was 8.73 meters. Before starting with reconstruction, I created a backup save, just in case. When everything is checked, we can begin with the reconstruction. On Reconstruction tab, first click on Settings. This image downscale we are going to set to 1, so the full image resolution is used for reconstruction. We already downscaled images in the beginning before we imported them in Reality Capture, so we do not need to downscale them further. Now we can click here on Normal Detail to start reconstruction. I got some error because of memory overflow. That is probably because of too many polygons. So I lowered vertex count in reconstruction settings. Default value was 5 million, I reduced it 10 times to 500,000 vertices. Reconstruction is now complete. We have two models in this component. Model 1 is the one with the error, so we can delete it. The reality capture is still showing the model as point cloud, not a polygon mesh. That is because of insufficient video memory. The model 2, which is successful reconstruction, has 200 million polygons. We need to reduce it now. Reconstruction tab, Simplify tool. I like to use relative method for polygon reduction. When the polygon count is reduced, we can now see solid mesh. When inspected it, I found some weird glitches. To try to correct this, I opened the project I saved as backup previously. Then we'll export component where everything is merged and open it in new project. Reconstruct again. This can take quite some time. For me, this run, which was now successful, took about 28 hours. I simplified this mesh to 1%. It looks good. Here is one issue I didn't notice in alignment. I'll have to fix it later in 3D program when cleaning the mesh. We can also clean the mesh a bit in reality capture. In selection, advanced, we can select all large triangles which are not needed. Adjust the selection with threshold multiplier. Check if selection is OK and click Filter Selection to remove selected polygons. Next is to clean up all these floating polygons. We do it by clicking on Select the largest connected component, then inverse that selection. Then check if everything is fine and deselect parts you don't want removed, like some of the trees and signs which are floating. Filter selection again to remove these polygons too. Now, because the road is the most important thing for our purpose and it has a lot of noise in it, we need to smooth it out. With Lasso tool we select only road polygons. Because the mesh is huge, selection like this can go a bit slow. To resolve that, we are going to create a clipping box, which makes visible only the polygons which are inside it. To smooth the polygons, Reality Capture has smoothing tool. I experimented with its settings and found the ones which suited best. Noise removal smoothing type works better than strong, and smaller smoothing weight with more iterations is good for noise removal, as the help says. Then we continue smoothing all the rod polygons. The smoothing is complete. It is somewhat good, but it will need more work in 3D program later. Some holes may appear in the mesh. Click Check Topology, then Clean Model to try to fix this. All the rest is left for cleanup in 3D program. Next, we need to texture the model. First, we'll import all texture folders, we need them now. Then, before making textures, we will unwrap the model. Unwrapping is something like projecting 3D polygon to a 2D map. This is a 3D model of a box, and this would be the same box unwrapped. I used 8K textures, fixed texel size and wrapping style, and optimal texel size in settings, which should produce maximum texture detail. Unwrapping produced 39 textures with 8K resolution. To generate these textures, we click on Texturize. This took 3.5 hours. Now we have reconstructed and textured 3D model, which we can export to 3D editing program for further manipulation. To export the model, we go to Reconstruction tab, Export, Model. I made new folder for export files. We will be using FBX format. These settings are all fine as default. When this is complete, in export folder we made, there is now FBX file and 39 PNG images as textures. This can now be imported to 3D editing software. I'm using Blender, so here is how it looks inside it. That would be all for this video. What has to be done next is mesh cleanup and setup for Assetto Corsa modding. I will cover that in the next video. I hope everything was clear in this one. I na kraju kompilacija niva.